Okay, I pressed the record button. Nobody gets extra points today. Maybe I'll come up with something if I never forget to record the whole semester, then everybody gets points. I'll think about that.
Seems like a dichotomous statement. I never or always.
I hate to have a situation where everybody's rooting for me to forget. That's not good.
But that was the incentive.
Yeah, good point. When you try to create an incentive, sometimes it's very hard because you can achieve one goal, but you have unintended consequences. So, and then you try to fix that, and then it's likely to continue to have problems. Okay. Well, all right. We finished our review of supply and demand last time. Remember, it's just so important to be comfortable with using the model. When you're told some event has happened, you visualize that graph. You draw the graph. You look at the event that has occurred, and you think, you have to remember to think, who's directly affected by this? Consumers or producers? Because that tells you which curve is going to shift. You take the time to draw the change. You look at the graph to see the change that has occurred, and then you read the results from it. The problem people have so often in economics is that they take shortcuts, and shortcuts will get you in trouble. So don't take shortcuts. Take time to use the model, and don't rely on your intuition. All right, today we're going to begin really the first of a whole bunch of applications of supply and demand. Chapter 5 is on elasticity, and it's extending what we have already said. We have said, the law of demand, what does the law of demand say?
Demands are limitless, and the resources are not.
That's true, and those are important things that we desires are unlimited, and resources are not, and that's basically scarcity. So that's really important. But the law of demand that has specific meaning. What does it say? Does the law of demand say when the price goes up, quantity demanded will always go down? No. The law of demand can be stated correctly as if the price of a product goes up, the quantity demanded of that product will go down, other things being equal. Okay? We know that there are lots of things that affect consumer decisions. Their income, the price of the good they're buying, price of substitutes, price of complements, all kinds of things that affect consumer decisions. The law of demand says if the price of a product goes up and everything else stays the same, then the quantity demanded will go down. That's exactly what the demand curve is showing. Price here, quantity demanded here. That negative slope is saying if the price goes one way, other things being equal, the quantity demanded will go the other way. So if it becomes more expensive, what do consumers do? Consumers are trying to figure out what's the best way to spend my money. So if one thing becomes more expensive, they decide this is not as good a buy. I'll buy less of this, more of other things. So the law of demand is reflecting the behavior of consumers as they try to use their limited income in the best possible way. But the law of demand doesn't tell us anything about how important or how significant their response is going to be. If the price of gas goes from $1.90 to $1.95, then we'd say, well, we expect consumers to cut back and use less. But how much less? Are they going to cut it by 90% or by 1%? Or will it just be so small you don't even notice? We haven't gotten into those kinds of questions yet. And that's the kind of thing we will get into in this chapter. And this will give us, focus our attention on some concepts that are really, really useful for understanding things that happen in real world markets. And to begin, we are going to start with an example. Let's say that you are a financial advisor to a retired baseball player. And he's well known. People would like to have his autograph. And so he signs his signs baseballs, and people pay him for that. Okay? And let's say that he has been charging $7 per autograph. He's famous, but he's not all that famous. So he's been charging that much. Okay? And something happens. He lives in Los Angeles, reading about all the fires going on in the West. Let's say that his house burns down. Let's say it's not covered by insurance. He's taking a big hit. He's thinking, I want to have more money. So the thought comes to his mind, I'm not going to charge $7 anymore. I'm going to raise my price. I'm going to charge $8 per autograph because I want more money. As his financial advisor, how are you going to advise him on this? Is this a good idea? Is it a bad idea? What do you need to know? Is it okay to just say, well, obviously, if you're getting $8 per ball, you'll make more money than if you charge $7? Is that obvious?
It's obvious, but it seems like it's too obvious. There might be something under it.
It's as obvious as it is to universities when they say, we'll raise tuition by 10%, and that means we'll get 10% more revenue. Seems obvious. You charge people 10% more, you get 10% more money. The problem with that is that it is ignoring what we just talked about, the law of demand. What does the law of demand say? Price goes up, quantity demanded goes down. A common assumption that people who haven't really thought about economics is that the law of demand doesn't really hold. They think you can raise the price, or a producer can raise the price, and it won't make any difference. Consumers will just buy the same amount. So if you're going to advise him on whether it's good for him to raise the price from $7 to $8, you're going to have to think about the law of demand. What is going to happen to the quantity demanded if he raises his price? And you may not have that information, but you're going to have to try to think about it. You're going to have to try to do the best you can to deal with the fact that almost always when price goes up, quantity goes down. Well, to allow us to illustrate our points, we're going to assume that we can actually go out and somebody has estimated the law of demand for this guy's autograph. Let's say this is what he's been doing. He's been charging $7 per ball, and the quantity demanded is 40,000. Okay? So he's thinking, well, I can charge $8 per ball, and I'll make an extra $40,000 because all these people who are buying it before, now they're going to pay $1 more. My revenue, my profit's going to go up by $40,000. But that doesn't take into account the law of demand. So let's say, well, actually, before we get into the demand curve, remember the producer's goal really is to maximize profits. And we need to think very carefully about what profit is because it's very easy to confuse profit with some other things. And I've seen people go halfway through this course and they're still having trouble remembering the difference between profit and some other things. So this relationship we have here is very simple. It's extremely important. And if you haven't thought about it, you may get confused. What is profit? It's the difference between total revenue, that's the dollars that the firm is receiving, and total cost. So you can say it's the dollars coming in minus the dollars going out. So profit is the gain to the producer. Yeah.
It always helped me to remember that profit was the amount of money coming in minus all of the bills that have to be paid.
Right, it's the money coming in. You said minus the bills that have to be paid. That is correct in terms of accounting profit. Where one of the interesting things we're going to see is there's a difference between the way accountants measure profit and the way economists measure profits. So I would tweak your definition and say profit is the difference between the dollars coming in and all of the costs that have to be covered. Okay. Sometimes there's a cost even though there's no bill. I'll explain what that means later when we talk about economic profit over in chapter 11, I think it is. But here, this basic idea is what's coming in minus the cost you incurred in order to sell all of that output. So it's the difference between those two things. It's the benefit that the producer is getting. So notice profit and revenue are not the same thing. What's revenue? That would be total sales, the total dollars coming in. Okay? And we're going to make an assumption until we get to chapter 14. We're going to make an assumption. We're going to keep it as simple as we can. We're assuming the firm is selling one product and they are charging one price for that product. Now, often, for chapter 14, we'll talk about price discrimination, where they charge different prices to different customers or different prices for different units. You know, buy one, get one, 50% off, something like that. But we're going to assume, until we get to 14, that the firm's only selling one product. They choose a price. They sell every unit they're going to sell to every customer at that one price. And so that means that the firm's total revenue, what's it going to be? What's it going to equal? If you're selling 1,000 units and you're charging $5 per unit, what's your total revenue? $5,000. And you got that just by multiplying the price per unit times the quantity, times the number of units being produced. Okay? So nothing complicated about that at all. But in your mind, you have to remember when you hear revenue, that's not profit. These are totally separate things. Revenue is the dollars coming in. It's equal to price times quantity. Profit is the difference between revenue and total cost. Okay? And what is the firm interested in? It's interested in maximizing its profit, okay? Not its sales, not its dollars coming in. And if you have a business that's bringing in $10 billion in revenue, well, that sounds good. But if it costs you $15 billion to receive that 10, things aren't going very well. Okay? So the distinction between profit and total revenue. Here is a hypothetical demand schedule. Okay? Let's assume that somehow we were able to estimate this. And so this is, first thing you notice is that this is just a demand schedule. It's showing different prices and it's showing the quantity that will be demanded at those prices. You can see as the price goes down, what happens to the quantity demanded? It's going up, as we would expect. When the price goes from, if it were 10 and the price were lowered to 9, then the quantity demanded would go up. Now, this totally arbitrary or hypothetical data, I have made two assumptions in creating this hypothetical demand schedule. One is that the law of demand does hold. Lower price leads to higher quantity. But also, just to make it a little easier, I'm assuming there's a linear relationship between price and quantity. Notice here, every time the price drops by $1, what happens to the quantity? It goes up by 10,000. Every time the price drops by $1, quantity demanded goes up by 10,000. Will that always happen? Certainly not. Okay, but it's just a little simpler to present it that way. Okay, and so if this is the case, then it means the demand curve is going to be a straight line. Okay. All right. So in red, I have what your client is currently doing. He's charging $7 per unit. He's able to sell 40,000 autographs. We need to, since he's interested in profits, we need to say something about both revenue and cost. And to keep this as simple as possible, we're going to, for now, assume that he doesn't have any cost. Basically, he's got a machine. Somebody has a machine that he signs his name once, and then the machine will copy that onto all the balls. We'll assume he's dealing with some firm that provides this service to him. So here he really doesn't have any cost. So his profit is just going to be equal to his revenue. Now, in real world situations, almost always you're going to have cost. But right now we're focusing on demand, we're focusing on elasticity, and so we can ignore the cost for the time being. Okay? So the question should be, when he raises his price, is that going to raise his revenue or not? He's assuming that it will. But notice here, if he raises the price by $1, the quantity demanded goes down by 10,000 units. And so what's going to happen to his revenue? It's going to go down because, remember, total revenue equals price times quantity. That's one of those relationships you don't need to have to think about it. By the time of the exam, you hear total revenue, in your mind you see price times quantity. So here we see we got the demand schedule, and now we have total revenue. We see that he's beginning $7, selling 40,000 units. He's bringing in $280,000 in revenue, which means $280,000 in profit, given that he has no cost. He wants to raise his price. Seems like a reasonable thing to do. Because of the law of demand, he's going to sell significantly fewer autographs. His revenue goes from 280,000 to 240,000. He's actually going to bring in less revenue if he charges a higher price. So what do you need to advise him to do here? You're going to have to tell him something that is going to be very counterintuitive to him. That's, no, you don't need to raise your price. You need to lower your price. And you think, well, that's crazy. I'm going to fire you. But if you understand what's going on here, it makes perfect sense. Because if he, rather than raising it, if he lowers it to 6, yes, he is getting fewer dollars per ball. But he is going to sell 50,000 more balls, more autographs. And he's not interested in the quantity or the revenue he's not interested in the dollars he's getting per autograph. He's interested in the total revenue he's receiving. And total revenue, as we said before, is price times quantity. So the revenue numbers here are just taking the price, multiplying by the quantity, and that's giving us total revenue. So we see that if he does, he's already charging too much. And if he lowers his price to $6, he's getting fewer dollars per ball, but he's selling so many more balls that his total revenue is actually going to go up. So we have an example here where we have a very counterintuitive result that if you cut your price, you'll bring in more revenue. Okay? How does that happen? Well, it's because of the law of demand. So the next question would be, well, is this always going to be true? If it is, then that would mean no matter what the price you're charging now, you should cut the price and you'll make more profit. But if you always cut the price, where are you going to end up? With the price of 0, which in most circumstances, that's not the price that's going to give you maximum profit. 15 years ago, I would say that's never going to work. Today, I have to say that's almost never going to work because we do have things like Facebook, we have things like Google, where they do charge a 0 price for their product, and they're making a lot of profit from doing that. That's because they're selling a product that has rather unique characteristics. And that is covered in the book, Network Effects, in chapter 16. We won't have time to cover that, but I really encourage you to read it because this is, as far as I know, the only textbook out there that covers that, had the foresight to cover that. So, question then is, in this case, lowering the price leads to more revenue and more profit. But we know that can't always be the case. So how do we know, how does a producer know when he should cut his price, when he should raise his price, or when he should keep it where it is? Well, we're going to see that it's very closely connected to elasticity. Elasticity, as we'll see, is a measure of sensitivity. Okay? How sensitive are consumers to a change in the price of the product? And I haven't explained how to calculate elasticity yet, but I'll go ahead and give you these numbers. Notice as the price is going down, the firm is able to sell more units. Notice when the price is really high and is cut, what's happening to revenue? It's increasing, goes from 100,000, 180,000, 240,000, 280,000, 300,000. Over these price ranges, by cutting price, revenue goes up. But then we see there comes a point where revenue is as great as it's going to get. Here it's 300,000.
Is that the point of diminishing returns?
Not exactly what we would call it. Diminishing returns has to do with production. When you're adding an extra unit of an input, how much effect does it have on what is the marginal product of that extra input? But it's an analogous idea that, you know, when you're charging a high price, cut your price a little, quantity goes up a lot in percentage terms. So you get a big benefit. But, and it might be a useful way to think about it, that, you know, if you're growing food and you're not using any fertilizer, and then you start using some fertilizer, that's likely to have a big effect, a big benefit. You use, 10 pounds of fertilizer on your field. It has a big effect. So maybe you add another 10 pounds and it has a positive effect. Okay? Just like here, you cut your price and it's beneficial. Cut your price again, it's beneficial. Okay? But at some point, it doesn't work the same way. Just, you put 10 pounds of fertilizer on it, you keep adding more fertilizer, output keeps going up. If you dump 1 billion pounds of fertilizer on this one field, at some point it's counterproductive. You're looking for the optimal amount of fertilizer to put on your field. Here we're looking for the optimal price to charge to give maximum profit. And here we see that as the price is lowered, consumers are buying more, revenue is going up, profit is going up, but if the firm continues to cut the price, then the revenue stops going up and it starts to go down. It goes from 300 to 280, 240. If you lowered the price to 0, what would the revenue be? Zero. Okay. So obviously that's not in the firm's interest. So one of the questions we'll deal with is, how does the firm decide the price that will give it maximum profit? We won't be able to fully address that yet because we are not bringing cost into the situation. But here we are dealing with what is the price that will give the firm maximum revenue. And we see that as they lower the price for a while, revenue goes up. And then if they continue to do it, revenue starts going down. Notice this last column over here, elasticity, which is our measure of how sensitive consumers are to a change in the price. Notice as the price is falling, as we're going down, that linear, well, it's supposed to be a linear demand curve. As we're going down that linear demand curve, what's happening to elasticity? It's decreasing, 6.3, 3.4. It's getting lower and lower and lower. In a minute, we'll see how that elasticity coefficient is calculated. But for now, I just want you to see that if the firm is relatively high up on the demand curve with high prices, demand will tend to be very elastic. As you move down the curve, if it's a linear curve, then elasticity gets lower and lower and lower, as we see in our numbers here. Okay? A piece of little bit of terminology that will be very important to remember. When the elasticity coefficient is greater than 1, we are going to say that demand is elastic. Okay? That's the term. So if I say the demand for product X is elastic, that means one thing. It means the elasticity coefficient for demand for that product is greater than 1. If the elasticity coefficient is less than 1, what do you think we're going to call that? Inelastic. Okay. N means not. So if I say your answer is incorrect, it means it's not correct. If demand elasticity is less than 1, then the label we use for that is inelastic. Inelastic demand. So notice at high prices here, elasticity is greater than 1. So over this entire range, we would say demand is elastic. And then down in this range, it has dropped below 1. We would say demand is inelastic. Okay, and notice in between elastic and inelastic, we have where elasticity is equal to 1. The third label you want to know is if the elasticity if it is I messed up my slide. If it is equal to 1, well, I'll just say it. If the elasticity coefficient is equal to 1, then we say that demand has unit elasticity. Okay. I'm going to close this out and hope that it comes back.
You said it has unit elasticity equals 1?
Right. Okay, I'm going to reopen this. Okay. So, let me just summarize that with a graph. If you have a linear demand curve, look for the midpoint on that curve. This midpoint between the two intercepts. Read down to the axis. We can say that over this range of that demand curve, demand is going to be elastic. Okay? The elasticity coefficient is going to be greater than 1. Over this range, demand is going to be inelastic, less than 1. And then right around that midpoint, demand is going to have unit elasticity. Okay? It's going to be equal to 1. Okay. Thank you. I do not believe it is screen sharing. There we go. Thank you. Okay, so let's talk a little more specifically about elasticity. There are actually different elasticities. The main one we're going to talk about is the price elasticity of demand. Okay? And measures how responsive or how sensitive quantity demanded is to a change in the price of the product. Okay? Just think about that. Where the question we're trying to answer with elasticity is, how much do consumers respond when the price of the product changes? Think about Bill Gates. Okay? Bill Gates goes to a restaurant and they raise the price of Coke from $2 to $3. You think Bill Gates is likely to change his behavior? Is he likely to say, oh, $3, costs extra dollar for a Coke, I'm not going to buy that? Probably not. He's probably not going to be very sensitive to a price change. If you have someone whose income and wealth is much lower, then they're much more likely to respond to that price change. That's what we're trying to measure with elasticity. We're talking about consumers. How much do they change their behavior? How much do they change the quantity they buy in response to a change in the price of the product? You want to remember, more responsive, more sensitive means more elastic. It absolutely depends on the item, and it depends on the person. If that's a good point to emphasize, that if elasticity was always the same for every good, for every person, well, then we could just find out, okay, elasticity is 1.3, and we wouldn't have to really talk about it. But it varies from person to person, from product to product. And for producers to have some understanding of what the customer's elasticity is very, very important. Because when especially if they can price discriminate. Because if the consumer is very sensitive to a price change, then they're going to be very reluctant to raise the price. If they know that the consumer is not sensitive to a price change, then they have an incentive to raise the price. If Bill Gates goes into the restaurant, and if they could set a price specifically for him, let's say they have electronic menus where everybody's menu is different. If they could set a price for water for Bill Gates, they'd probably set it at $100. He's not going to walk out. He's probably going to notice. So it's very useful for producers to have some idea how sensitive consumers are to a price change. Now, many producers, if you ask them, how elastic do you think consumers are, the demand for your product, many of them are going to say, what are you talking about? What is elasticity? Okay? So they may not use that term, but they if they know what they're doing, they are definitely very concerned about sensitivity. So elasticity is the term we're using to measure this thing that all the producers are very interested in. Important thing to note is that elasticity is not the same as the slope, but they are related. Think about what we've already said. We said that if we have a horizontal demand, if we have a linear demand curve, as I have here, more or less, what's happening to the slope as you move along that curve? As you move along the curve, the price is going down. But what's happening to the slope?
Does that mean
I'm sorry?
I didn't hear what the last thing that you said.
If it's a linear curve, then as you move along the curve, what is happening to the slope? Is it changing? If it's a linear curve, then the slope is constant. Okay? In our example earlier, every time the price went down by $1, the quantity demanded went up by 10,000. So that was a constant slope along that demand curve. But we saw that the elasticity was not constant. Okay? The elasticity, when you're high up on the curve, tends to be rather high. When you move to lower regions, it tends to be rather low. The slope, if you started here and you lowered the price so that the consumers are buying more and more, the slope would not be changing here, but the elasticity would be changing. Okay? So slope and elasticity, similar, well, they're related, but they're not the same thing. Notice the elasticity rule. If two linear demand or supply curves run through a common point, then the curve that is flatter is more elastic. So if we have D1 and D2, and let's say this could be the demand for a certain drug, demand for ibuprofen, let's say. This could be the demand for ibuprofen in one market, one area, and D2 could be the demand in a different area or different country. Okay? Let's say that the price is $5. Then the quantity demand is going to be something, let's say 10,000 units. If I gave you this question, you have these two demand curves. I say at a price of $5, which curve is more elastic? Which would it be?
Demand two?
It would be D2. Okay? It would be D2 because at any given point, if the curves are intersecting, the flatter one is going to be more elastic. The steeper one, I'm sorry, let me restate. At any given point, the steeper curve is going to be less elastic, which means more inelastic. Flatter would be more elastic. Okay? And I believe our next slide, yeah, look at this one. Start out at point A. The price of this product is, I think that may be talking about oil. It doesn't really matter. At that $40 price, the quantity demanded is 100. In demand I, okay, it's supposed to be demand L. I'm going to call this demand 2 and this demand 1, okay? In this second market, okay, notice if the price goes from $40 to $50, what happens to the quantity demanded? What's the change? We go from 40 to 50. We move from this point on, okay, if we're looking at demand 2, okay, that'll be this curve, the steeper curve. When the price goes from 40 to 50, we move from point A to point B, which means the quantity demanded goes from 100 to 95. The $10 change in price led to a 5-unit change in the quantity demanded. Okay? Whereas if we were looking at market 1, okay, a flatter curve, you have the same $10 change in price. What happens to the quantity demanded?
It's gonna go,
It goes from point A, 100 units are demanded, quantity, to this point where only 20 units are demanded. So with the steeper curve, where demand is less elastic, the $10 change in price had really very little change in what consumers bought. But in market one, where the curve is flatter, the same $10 price increase causes quantity to go from 100 all the way down to 20. Huge change. So in that demand one, the one I'm calling one, you had a huge responsiveness to the change in price, where you had a much smaller responsiveness in the other market. Yeah, this shows that same thing, right? Where they've set that up so that you're looking at the same price change in both markets. You see a much bigger response in one market than in the other. Okay. The determinants of elasticity. In that last graph, we saw that one demand curve can be much more elastic than another. We saw what that meant. But now the question, well, what causes one demand curve to be more elastic? What causes consumers of one product to be more sensitive to a price change than consumers of another market? And these are the key things that are almost always important. First, okay, future slides we'll get to how we actually do the calculation, but now we're talking about it in intuitive terms. First, ease of finding substitutes. Substitutes, really the key to elasticity. Okay? If you I need coffee. You know, every morning I need coffee. If there was only one place that I could buy coffee, and they raised the price for a bag from $16 to $32. Okay? That's a big change in the price. Okay? I wouldn't like that. But if that was the only place I could get coffee, I would still buy just as much, or almost just as much. Okay? Very little sensitivity, because I don't have any good substitutes for buying coffee from that producer. On the other hand, if I've got 15 different stores I can buy from, and one of them raises the price of coffee 10%, but I've got 14 other producers who are offering coffee that to me is just as good, then I may cut the amount that I buy from that initial producer almost to zero. I may have a huge, dramatic change in the amount that I buy because I've got lots of good substitutes. So we can say that the easier it is to find a substitute and to find a good substitute, the more responsive consumers will be to a price change. And that means the more elastic the demand for that product is going to be. So if we're talking about my demand for coffee in the situation where I've only got one supplier, one choice, I have no substitutes, what would my demand for coffee look like under those conditions? I'm sorry?
no substitutes.
If I have no substitutes, then well, it's going to be not just linear, or it could be linear. We don't really know. It's going to be vertical or close to vertical. If I literally will buy the same amount no matter what the price is, then it would be vertical. And that situation is called being perfectly inelastic. Perfectly inelastic means no sensitivity to the price at all. Okay? Price goes up, doesn't matter. Quantity demanded is going to be the same. If I'm going to buy 2 pounds of coffee from this producer each week at a price of $16 per bag, if my demand is perfectly elastic, and if he raises it to 32, I'm going to buy exactly the same amount. Okay? And
Do all three of these steps whenever they release the product.
I'm sorry, I'm having trouble.
Companies do these 3 steps within themselves whenever they release the products.
The company, they have to think about this. 'Cause if they don't, yeah, they're going to get.
Like, for example, take Marlboro, for example, they'll release a new type of cigarette and they'll lower the price to like 5 or something, whatever, everything else is 7 to get people to go to them because they're cheaper than just raise the price.
There are all kinds of pricing strategies that firms can use to increase their profit. And their goal is to make profit. Doesn't mean that it's an evil thing for them to do these things. But if you understand what they're doing, sometimes you can save a lot of money. For example, when a new book comes out, okay, usually almost always they come out in hardback. Okay? And what is the price of a hardback when it first comes out? It's very high. Okay? And then at some point, they come out with a paperback, and a lot of times it's dramatically cheaper. And part of that price difference would be that, oh, it doesn't cost as much for them to produce a paperback as a hardback. But I think in a lot of situations, it's not really the cost difference that matters. It's the elasticity of demands. If you have a new Harry Potter book comes out, you've got people who are crazy about Harry Potter. They can't wait to get their hands on it. They're willing to pay a very, very high price for it. So they come out with the hardback with a really high price, and the fanatics, they buy it. People who aren't that into it say, I'm not going to pay that. I'll wait. There are people who are willing to wait longer to save money. So they charge the high price at first on the hardback, and then they cut the price later on. And that a lot of what's going on there is they're distinguishing between the people who have a very inelastic demand for the product and the people who are much more price sensitive. So if they can do that, they can make a lot more profit. And sometimes making more profit can really be the difference between surviving and not surviving. One of the industries that does the most price discriminating is the airline industry. I mean, you have a plane with 100 people on it. They may have paid 100 different prices. It's a huge amount of price discrimination, and that makes them more profitable. But even with that, the airlines often file for bankruptcy. It doesn't guarantee that they're going to be able to survive. Anyway, elasticity is very useful in helping us understand pricing decisions by firms. And the number of substitutes and how good the substitutes are is a critical factor. Think about we always talk about the demand for something like insulin. If you're a diabetic and your doctor says you really need a certain amount of insulin each day to function well, what is your demand for insulin going to look like?
Could be,
It could very easily be vertical. Okay? If he says you really should have 15 units of insulin a day, okay, well then if the price is 10 cents, that's how much you use. If it's 30 cents, you don't say, well, I better cut back because no, you're going to want to use the same amount. Okay? There are no good substitutes, as far as I know, if you're a diabetic for insulin. So because there are no good substitutes, the demand is very, very inelastic. Even though there are things you can do, you can vary the food you eat, you can vary the amount of exercise you get, that you will enable you to vary the amount of insulin that you use. Okay? And that would be very inconvenient to have to change what you're eating, change your exercise. You wouldn't want to do that. But if the price goes up a lot, then you would choose to do that. And if the price goes up enough, even for something like insulin, it starts to look like that. Okay? There are no good substitutes for insulin, but if the price is high enough, the person just doesn't have enough income to buy the same amount. I remember reading last year about the price of insulin has increased dramatically in recent years. And reading about this guy who did not have the money to buy the amount of insulin he was supposed to have. And so he was doing things to try to get by with using less insulin. Not because he didn't want to use the insulin, but because he didn't have the money. And he ended up dying. But it illustrates that the price goes up enough, then any demand curve starts to become more elastic, simply because people don't have enough income to keep purchasing the product. The second factor listed here is also very, very important. The time to adjust to, let's go back to the substitutes for a second. You're a producer, okay? And you're trying to decide what price to charge for your product. Okay? If the market changes so that there are new substitutes for your product, then you better take that into account and recognize that your consumers are going to be more elastic, and so you may find it in your interest to cut the price. If something happens where the consumers had a lot of substitutes before, but now they don't, maybe the supply of another product has been eliminated. If they have fewer substitutes, what does that mean about their elasticity? Their demand for your product is going to be less elastic, which means the price that will give you maximum profit is now going to be higher. If you're just going to maximize your profit, you will raise the price. Now, you can go into the question of, well, is that ethical? There's an ethical dimension to pretty much everything we do. But what we're focusing on here is simply identifying what is the price that will give maximum profit. And if the number of substitutes available to the consumer goes down, its elasticity is going to go down, price that will give maximum profit will go up. All right, now time to adjust to a price change. Let's say that it is 1 week before the beginning of the fall semester. Anybody remember what tuition is per hour? Per hour? Or per semester for a full load? I should. I was paying it for one of my sons recently, but I don't remember. Let's say it's $2,000. That's probably too low. Let's say that given that that's what tuition has been in the past, let's say that the number of students who enroll is 3,000 at that rate. Right? For 1 week, this is the number of students, and this is the price, tuition. And let's say that it's 1 week before the semester begins and the university announces, we've changed our mind, and we're going to raise the tuition to $4,000 for a full load, okay? That's not gonna happen, okay? This is just an example. What difference does it make that it's 1 week before the semester begins?
There would be fewer substitutes because somebody's there would be students who've already written the checks.
You don't have very many substitutes. If it's 1 week before the semester starts, you know, maybe there were 100 other schools you could have gone to, but if you only have 1 week to adjust, your options are to stay here or go or not go to school. Okay? And so I would suggest to you that the quantity demanded would certainly go down because some people would say, I don't have the money, I can't pay it. But it wouldn't go down all that much in the fall semester. Okay? Let's say it goes to 2,500. And that means that these 2 points would be points on the demand curve for an LSUA education, given only 1 week for adjustment. Because you had very little time to adjust to the price change, responsiveness would be relatively low, demand would be relatively steep, demand would be relatively inelastic. But compare that, start over, we're here at $2,000 and $3,000 enrollment. What if it's announced that a year from now, tuition is going to be doubled to $4,000? Okay? Well, now people have a whole year to find alternatives and to apply to other schools and make housing arrangements. You got lots of alternatives if you have a year to adjust. So the same price increase wouldn't cause enrollment to drop a little bit. It would cause enrollment to go down dramatically. Okay? So with 1 year, maybe it would go down to, let's say, 1,000. So we're saying that students, the consumer, would be very sensitive to a tuition increase if they have a lot of time to adjust. And so that demand would be very elastic. But if they have only a small amount of time to adjust, their demand would be rather inelastic, much steeper. So here we're talking about the same market, same product, same group of people. The only thing that differs is how much time do they have to adjust to a price change. Think about gasoline. If the price of gas went from $2 to $6, and you only have a week to make adjustments, you don't have very many substitutes. And so the demand would tend to be rather steep, rather inelastic. But if the price goes from $2 to $6, and we say, well, we'll give people a year to adjust and see how they're going to respond. would suggest to you that the demand under those conditions would be, excuse me, much more elastic. What substitutes would be available over a year that wouldn't be available over a 1 week period?
Like public transportation or car.
Most people, you know, if gas is cheap, you probably don't even know what the public transportation's options are. Carpooling, maybe somebody that you could easily carpool with, but if gas is cheap, you haven't even looked into that. But the longer the time you have to adjust for price changes, the more time you have to look for substitutes. And then because you have more substitutes, your demand is going to be more elastic. If you live far away, so if the price of gas is low, you don't worry about it. The price of gas triples, then people who live far away are likely to move. They're likely to buy a more fuel-efficient vehicle. Some people might buy motorcycles rather than drive a car. You got lots of options if you have time to think through those substitutes. But with only a short amount of time, you don't have many good substitutes, so the demand can be very inelastic. All right, last thing. Get back to where we were. Okay, there are two more determinants of elasticity we'll come back to next time. But here's what you want to be thinking about before next time. To calculate the elasticity of demand, we said what it represents. It's how sensitive consumers are to a change in the price. But how do you measure that? Well, elasticity is a ratio. It's giving you the percentage change in the quantity demanded divided by the percentage change in the price, okay? As you see here. Okay? It's just a ratio, okay? One change to another change. You're measuring those changes in percentage terms, and the key thing to remember, in the numerator, you have the percent change in the quantity demanded. And in the denominator, you have the percentage change in the price of the product. Really, elasticity is telling you the response of consumers that results from some change in the price of the product. So, for example, if you had an elasticity of 1.5, okay, that would mean the percent change in quantity demanded over the percent change in price is 1.5. Okay? And you could think of that as 1.5 to 1. Okay? What would that mean? It would mean if the price changes by 1%, what's going to happen to the quantity demanded? It's going to change by 1.5%. Okay? So if demand is elastic, you get, even if you get only a small change in the price, you get a big change in the quantity demanded. If it's inelastic, even if you get a big change in the price, you get only a small change in the quantity demanded. We're always measuring those changes in terms of percentage changes, okay? So next time we will go through some examples of how you do that calculation. We'll finish talking about the determinants of elasticity. We will talk about a little bit about the elasticity of supply. We'll talk about two other elasticities: income elasticity of demand and the cross price elasticity of demand. We won't say much about those, but they're all basically dealing with the same thing. By how much does some quantity change in response to something else? usually the price, but we can also talk about income. Okay. Any questions? All right. Let me know if you do have questions.